Okay, so we're going to go over the problem set with the answers that you should have in preparation for the unit test you will take tomorrow. So number 1 says a shorter style of cups is stacked tall. The graph to the right displays the height of the stack in centimeters for a different number of cups. How much does each cup after the first add to the height of the stack? Explain how you know. So what I want to do, or what you could do, is actually find the slope of the line that will give you an indication of how tall each cup is after the first cup is added. So you have 2 points that are outlined on the graph. You have 3 and 5.5 and 8 and 8 as your 2 points. And as we learned in class, you can find the slope of any line with 2 points by finding the change in the y values, so 8 minus 5.5, over the change in x values, so 8 minus 3 in the denominator. So 8 minus 5.5 ends up being 2.5 over 8 minus 3, which is 5. And if you take the math and simplify this down to a number, because we're looking for the height that is added per cup after the first cup, you end up with a number of 0.5. So that means 0.5 centimeters in height is added after the first cup. Okay? Okay? So that's how we figure that out for the first one. So we did that by finding the slope between 2 points of the line to determine the height that is added after the first cup. Number 2 says the graph shows the savings in Andre's account. What is the slope of the line? And then what is the meaning of the slope in this situation? So again, in order to find slope, you can find 2 points. So we know we have a point at 0.40 right here. So I'm going to write 0.40. This is part A that we're solving for. And then there's another point at 460 that we can say. So we're going to have the point 460. So now let's find the slope. So we're going to do 60 minus 40 over 4 minus 0. So 60 minus 40 is 20 over 4 minus 0 is 4. That comes to 5 as being the slope of the line. Okay. So then B says, well, what is the meaning of the slope of that line for this situation? So if we look at our labeling of our graph, the x-axis is our time in weeks, and while the y is the savings in dollars. So that tells us that Andre saves $5 per week is what our slope tells us. Okay, he saves $5 per week according to the graph. Okay. We also talked about in class as to what does it mean for the y-intercept of this line. It's not a question that's in the problem, but it's a question that we certainly should be able to answer. And that is, he started out with $40 already in his savings account before he started saving $5 per week. So that's why the graph does not start at 0, 0. Okay. All right, number 3 says make a sketch of a linear relationship, in other words, a graph of a line with slope of 3 that is not a proportional relationship. Show how you know the slope is 3, and then write an equation of the line. So I've already prepared a coordinate grid for us to use, or for me to use in order to figure this out. So we talked about in class today that when it is not a proportional relationship, the graph does not start at the origin. Here is the origin of my graph, of my coordinate grid. So I'm not going to start there because this is not a proportional relationship. So I can start anywhere but the origin. So in this case, let's start right here at, we can call this -2, okay? This will be point -2. So now I need to have a slope of 3, it says. So in order to graph a slope of 3, I'm going to use that in order to count it out. So I'm going to go up 3. So that's 1, 2, 3, and then to the right 1. This is my next point on my line. And I can repeat that process again from this point to gain more clarity of my line, or to make a more precise line. So I'm going to go up 3. So 1, 2, 3, to the right 1. There's my next point. And the more points you have on your line, the easier it is to draw an accurate line. So let's try one more. So 1, 2, 3, and then to the right 1. And then use your ruler, your straight edge tool, to help you graph your line without any bends in your line. Remember, we can make straight lines when we have a straight tool to use. So this is how your line should look with a slope of 3. And then the question said, the problem said, how do you know it is a slope of 3? It is because we are able to use slope triangles if we want in order to figure out the line, or we can count. So again, 1, 2, 3, and then to the right 1, so that we know from this point to that one, it is a slope of 3. If you really wanted to, you could put numbers to this. So this would be 1, 1 right here. And then this point here would be 2, 1, 2, 3, 4, 2, 4. So if we were to calculate the slope based upon our points, we would have 4 minus 1 over 2 minus 1. 4 minus 1 is 3. 2 minus 1 is 1. So there's our slope of 3. Okay. Then it says to write an equation of the line. So there are 2 ways that we learn how to write an equation. We could do y minus 4 over x minus 2 all equal to 3. That would be our slope equation, or an equation of the line. Or we could write it as y equals 3x minus 2, because my line crosses the y-axis at -2. Okay? And so remember how we use a point to write the equation of a line this way in the very beginning, and then we learn how to write it this way towards the end of the unit. So either of these will work for the equation of your line. Okay? All right, number 4 says describe how the graph of y equals 2x is the same and different from the graph of y equals 2x minus 7. Explain or show your reasoning. So we did learn, so let's talk about what's the same, because we learned about that a while back. So we learned that when you have y equals 2x here and y equals 2x, we can presume or say that the slopes are the same. Okay? The slopes are the same, and this will create, remember we talked about, this will create parallel lines. Because any 2 lines that have the same slope will be parallel. They will never intersect. Okay? Now, what is different about these 2 lines, this one says y equals 2x, and this one says y equals 2x minus 7. So they have different starting points. Okay? So they have different starting points. So one graph will start at 0, 0, or the origin. And the other graph will start at 0, -7, because it crosses the y-axis at -7. Okay? So those are the 2 starting points that are different from the equations. Okay? So anytime you have a graph or an equation that says y equals 2x, 3x, whatever it is, times x, and there's nothing being added or subtracted, it starts at the origin. If it has a number that's being subtracted or added to it, then that's where it starts on the y-axis for that number. So if it would have said 2x plus 7, it would have started at 7 on the y-axis. Okay? All right, number 5 says you are to calculate the slope of graph D. Explain and show how you know that that is the slope. And then B says calculate the slope of graph E, and then write the situation that would represent, that you could use the graph to represent. And then C is we're going to draw an actual line using that point that has a slope of -2. So in order to find the slope of graph D, let's find 2 points that are clearly on the line. So we have here and here. And we can go back to our counting method like we did when we learned about slope or slope triangles. So we're going to count our vertical rise in this case, and it's going to actually go down. So we're going to go from, or we could go up this way and that way. It doesn't matter. You can go down and to the right or up and to the left. It doesn't matter. Okay. So I'm going to go down. So 1, 2, 3, 4. I go down 4 and then to the right 1. So that would tell me that my slope is -4 over 1, or just simply -4. And we know because we used slope triangles, you could talk about that, or you could talk about just counting the slope. Okay, just counting slope as another way of saying it. All right. So you have your 2 points to help show that you use those points to find slope. All right, graph E. We talked about this kind of line in class. This line is a horizontal line. So we know the slope of a horizontal line is 0. Okay? 0. There is no rise to that line. There's only a run. So that would be 0 over whatever number you choose, thus indicating that the slope is 0. So what situation could the graph represent? So remember in class we talked about the bus situation. So this could represent a bus pass that is not used over a course of time. That's one situation that you could use to describe the graph, or the graph could be used to describe. It could be used, you could say that this is a savings account where there was no money added or taken out for a duration of time. It could be used to represent a car sitting still at a stoplight. There are different situations that you can describe, that this graph could be used to describe. Okay, so it doesn't have to be any one, but just as long as we understand that there was something that didn't happen over a period of time, such as no money was added to the account and none was taken out, or there was no usage of the bus pass for a certain amount of time. Okay, so graph F says to draw a line that passes through the indicated point here and has a slope of -2. So that means I'm going to have a downward line because my slope is negative. And so we're going to start here, just like we did when we found the slope in graph D. We're going to use it to make a line. So we're going to go down 2. So these lines are kind of faint. So 1, 2, and then to the right 1. So our point would be here. And we can do that again. Down 2, 1, 2, and to the right 1. So our next point would be here. And then we would take our straight edge tool and connect the points to create the line, showing that we have a slope of -2 of our graph. Okay? And that will be all that you would do for that particular line. Okay? All right, number 6. This is the one that we did in class, and I want to make sure I go over and clarify what we were thinking, because the labeling of the axes is what got us in class. So let's look at it. So it says on the same axis, so the graph to the right represents the positions of 2 turtles in a race. So you have these 2 turtles in a race. On the same axis, draw a line for a third turtle that is going half as fast as the turtle described by line G. So let's look at line G in detail. So we have distance here as our Y, as our X, and the time that it takes to travel that distance as our Y. So let's look at this in the reverse way we looked at it in class. So turtle G, okay, travels 2 centimeters per second. So let's look at, so line G, so 2 centimeters per second is the travel speed of the turtle. If you want to go further, you have 4 centimeters per 2 seconds. Okay, so we're looking at 2 centimeters per second. So half as fast, which means in the same amount of time that turtle G travels, we have a third turtle that's traveling a different type of speed, but at the same time frame. So if line G is 2 centimeters per second, half as fast of that would be 1 centimeter per second. So when we graph this, we're going to look at 1, 1 as our first point for the third turtle. Okay? So basically, it's a 1-to-1 ratio more so than what we thought of. When we did it in class, we found the slope of the line and found that the slope of the line was 1/2. But we have to reverse the thought, because we got to think of it as distance traveled over time. So when we did 1/2, it was a time over distance. Now we have to do distance over time to figure out the third turtle. So it is 2 centimeters per second that we found out, but we just have to reverse it. So now the third turtle is going to go 1 centimeter per second. Okay, so 1, 1, 2, 2, 3, 3, 4, 4. Okay, so this would be how the turtle would travel for the third one. So you got 1, 1, 2, 2, 3, 3, 4, 4, and so on. Let's draw a line. So it's going to be quite the opposite of what we thought when we did it in class, just because the numbers and how they're presented on the graph are not the way that we normally do it. So let's trying to get my line straight. So this will be the line of the third turtle. Okay, this is the line of the third turtle. Let's call this turtle M, the third turtle. Okay. So explain how your line shows that turtle is going half as fast. So you could look at the travel time. So if line G is 2 centimeters per second, so line M, which is our third turtle, it travels 1 centimeter per second. So same time frame of travel, just half the distance that's going, okay? So in 2 seconds, line G should be 4. So 2 seconds, 4. 2 seconds at 4. So 2 seconds, 4 centimeters. So therefore, this one would be 2 centimeters, 2 seconds. So 2 centimeters, 2 seconds. The half as fast, okay? So I just want to clarify that from what we thought about in class, because we looked at a different aspect. All right, number 7 says, using the graphs to the right, which of these relationships is different than the other 3? Explain how you know. So when you find, so let's say graph A, we find the slope of graph A, we end up with the point that is on the line is 0.84. So let's look at it as our slope. So up 4 and over 0.8. So if we do 4 over 0.8 and find the numerical value of that, so 4 divided by 0.8, you end up with 5. So the slope is 5 for graph A. Graph B, the point that they give us is 55 over 10. So we go up 55 and over to the right 10. So 55 over 10 gives us a slope of 5.5 as a slope. Okay, let's just look at C. We go up to 20 and then over to 4. So 20 over 4 gives a slope of 5 for the slope. And then graph D, the point that they have here is 45, 50. So 50 over, sorry about that, 50 over, this is 10, 20. So that would be 50 over 10. So if I have 50 over 10, that ends up being a slope of 5 as well. So the one that does not fit is graph B. Okay, does not fit. And we know that because the slope is different from the other 3. Okay, that is number 7. All right, number 8. This says to sketch a graph that shows the relationship between grams of honey and grams of salt needed for a bakery recipe. Show on the graph how much honey is needed for 70 grams of salt. So we're going to look at this as being our salt is our X, our honey is our Y. And the lines on my graph, on my coordinate grid, are a little bit faint. So I'm going to forego actually graphing the line, but you could, of course, at home. We're going to create ordered pairs out of this. So we have an ordered pair of 10, 14, and then 25, 35. Okay? So if we go back to what we know about slope and using 2 points, let's find the slope of the line. So 35 minus 14, I like to keep my numbers positive when I can. So 35 minus 14 over 25 minus 10. So 35 minus 14 is 21. 25 minus 10 is 15. So if we reduce this down, we end up with 7/5 as our slope. So if we write an equation, let's presume that if you have no salt, you have no need for honey. So our equation would be y equals 7/5 x. So if x is our salt and we know we need 70 grams of salt, let's plug in our numbers and see. So what is the value of y when you have x at 70? You end up with y equals 98. So you would need 98 grams of honey if you have 70 grams of salt. Okay? 98 grams of honey if you have 70 grams of salt. And again, you could graph this, but the lines are so faint, I don't even want to attempt to try to make this a perfect graph or a nice graph. I mean, I can see the first 2 lines and then it fades and then it comes back, so I just don't want to do all that. Okay? All right, number 9. It says here are 2 recipes for 2 mixtures of salt and water that taste different. Information about salt mixture A is shown in the table. So again, let's make order pairs. So this is 4, 5, and this is 7, 8, and 3/4. And this would be 9 and 11 and 1/4. So let's use 2 of these to find the slope. So they tell us here that the salt mixture B is defined by the equation y equals 2.5 x, where x is the number of teaspoons of salt and y is the number of cups. So if we take our order pairs, we're going to figure out how much you would use if you have 10 cups for each mixture. So let's find the slope, because we know the slope of mixture B. This is the slope of mixture B. We know that. Okay, let's find out what it is for mixture A. So let's do 5 So let's, right here, let's do 8 3/4 minus 5 over 7 minus 4. So 7 minus 4 we know is 3, so we're going to put that down there. So 8 3/4 minus 5 should be 3 3/4, or 3.75. So 3.75 divided by 3 ends up giving us 1.25 as a value. So 1.25. So mixture A has an equation. I'm going to write it right here. Mixture A has an equation of 1.25x for mixture A. So now let's use our equations to figure out how much is needed for 10 cups of water. So if we use 10 cups of water, okay? So let's do 10 equal to 1.25x for the first one, and then 10 equal to 2.5x. So let's divide both sides by 1.25 to figure out how much salt we would have. So 10 divided by 1.25 ends up being 8. So 8 is here, and then divide this by 2.5. 10 divided by 2.5 ends up being 4 equals x. Okay? I think in class we ended up putting 10 for x as opposed to 10 for y, because y is the number of cups of water. We did not do that in class, I don't believe, the number of cups of water. So if we use 10 cups of water, which one would use more salt? So here we have 4 teaspoons of salt being used for mixture B and 8 being used for mixture A. So mixture A uses more salt. Mixture A uses more salt because of how we should have done it, and how we should have done it in the sense of 10 cups of water was used. So that's our y value. We put 10 in for x and not 10 in for y. So B says, which mixture tastes salty? Explain how you know. So then it would be mixture A tastes saltier, or has the saltier taste. Tastes saltier. Sounds strange saying it that way. And we know that because more salt is used for, not an E there, for the same amount of water. So actually use twice as much salt for the same amount of water. Okay? So again, make sure we look at that. I just realized that when I was going back over it. Okay? All right, number 10 says, without graphing, find the slope of the line that goes through these points. So for A, we're going to, again, use the points. So we're going to do 2 minus 5 over 8 minus 0. 2 minus 5 is negative 3. 8 minus 0 is 8. So our slope is negative 3/8. B, I'm going to do 1 minus negative 1 over 6 minus 2. 1 minus a negative 1 is going to end up being 2, because that becomes 1 plus 1. Ends up being 2. 6 minus 2 is 4, so it ends up being basically a slope of 1/2. And then C, I'm going to do negative 5 minus negative 2 over negative 1 minus negative 3. So negative 5 minus negative 2 ends up being negative 5 plus 2, which makes it negative 3. Negative 1 minus a negative 3 ends up being negative 1 plus 3, which ends up being 2. So our slope is a negative 3/2. Okay. All right, number 11 says write an equation for the lines A, B, C, D, and E. So line A is here. It is a vertical line, and we learned in class that vertical lines have an undefined slope. So when we write the equation, it ends up being x equal to wherever it crosses the x-axis. In this case, it is negative 4. B is also a vertical line, so therefore it would be x equal to wherever it crosses the x-axis. In this case, it is 4. C is a horizontal line, so we learned that a horizontal line has 0 slope, so therefore it never crosses the y-axis. I'm sorry, it never crosses the x-axis. So it would be y equals, in this case, is 4 because it crosses at 4. D is also a horizontal line, so therefore it doesn't have a slope, or the slope is 0 rather. So it crosses at negative 2, so y equal to negative 2. Okay. Now, line E is a little bit different because it does actually have a slope that is not undefined or 0, and it has a point where it crosses the y-axis. So if we use our slope counting ability, so let's go from here to there. So let's count up 1, 2, 3. And then to the left, 1, 2, 3, 4. So we have a slope that's negative. So we can do y equals negative 3/4 x. So again, 1, 2, 3, and then 1, 2, 3, 4. So up 3, to the left 4. And it crosses the y-axis at 1. So we will write plus 1. Okay, so y equals negative 3/4 x plus 1. Okay. Number 12, which of the following coordinate pairs make the equation x minus 9y equals 12 true? So this is what you do to figure that out. So you're going to plug in the values, x coordinate for x value. So 12 minus 9 times 0 equals 12. Well, 12 minus 9 times 0. Well, 9 times 0 is 0. 12 minus 0 is 12. So that is true. B says, well, think about it. If this is true, then the reverse probably is not true. So 0 minus 9 times 12, is that equal to 12? So 0 minus 9 times 12 is 108, if I'm not mistaken. And so 0 minus 108 is not going to be 12. So this is not true. You end up being a negative 108 equal to 12, which is not true. This is 12 equal to 12. So C, let's look at it and see if it's true. So 3 minus 9 times negative 1 equal to 12. Well, 3 minus 9 times negative 1. So 3 minus a negative 9 times negative 1 end up being minus a negative 9. And then a minus a negative ends up being plus a positive. So it ends up being 3 plus 9 equal 12. And we know that 12 is equal to 12. Okay, sorry about that. Then the last one, letter D says 0 minus 9 times a negative 4/3 equal to 12. So you end up with 0 minus, minus 9 times a negative 4/3. So this ends up being, well, think about it. 9 times a negative 4 is a negative 36 over 3. So minus a negative becomes plus a positive. So 0 plus 36 over 3 is 12. Equal to 12, so that means 12 equal to 12, so therefore it is true. So all but B are true based upon the math that we just did. Okay, so there's the math that we just did. All right, so again, number 13, the lines are very, very faint, so we're going to do the math to show how we know whether or not these line up. So let's find the slope given the information. So a graph of a linear equation passes through the points negative 2, 0, and 0, negative 6. Use the 2 points to sketch a graph of the equation. So let's find the slope. So if we do negative 6 minus 0 over 0 minus negative 2, negative 6 minus 0. So we end up with negative 6 over 2, which gives us a negative 3 for the slope. So we could start at either these 2 points and then graph more points with our slope, okay? So then it says, is 3x minus y equal to negative 6 an equation for this graph? Explain how you know. So I'm going to put B's answer down here. And you could graph to see if they're the same, but we don't need to. Because our slope here is negative 3. If we rearrange this particular equation so that we have an equation that's very similar to what we would have written for this one. So let's say we start out with this one for the equation y equals negative 3x and whatever else it may be. It could be plus 3, we don't know. But we do know that the slope is negative 3x. So let's rearrange this equation so that our slope, we can figure out what our slope is when y is by itself. So you have 3x minus y equal to negative 6. So I'm going to move the y over, plus y to get 3x equal to, let's say y minus 6. Okay, now let's get the y by itself. So we have 3x equal to y minus 6. So let's add 6 to both sides. So you end up with 3x plus 6 equal to y. So looking at this equation and looking at that one, this slope here is a positive slope. This one here is a negative slope. That will tell us that this cannot be the equation for those 2 points. okay, that this equation here in part B is not the same for this particular set of points. They're different. One slope is positive while the other is negative, and that would be our difference. Okay, and if you wanted to graph it, you could, but I will use a graphing paper to show the lines so that you can clearly see the points. But right now, the way this coordinate grid is set up, you can't see those lines. So it's trying to do this on this paper would not show the true relationship of the lines for the equation. All right, that's your problem set. Make sure you review and study. And if you have any questions, you can send me a message through Remind to ask. Have a good one, guys. Bye.